Welcome to Trimble Business Center. In this video we'll be talking about the ADAC utility that's been written for TBC. ADAC stands for Asset Design as Constructed. It's the IPWEA data standard for public works and spatial data, such as cadastral, sewerage, and other utilities. If you haven't heard of it before, you can go to the IPWEA website to have a look. There's quite a few jurisdictions in Australia using ADAC, and it's growing at the moment, so it's not a bad standard. It's part of the data harmonization XML formats, which can be easily exchanged between any of the participating software platforms. This diagram shows the categories it's used for and the features collected for each category. Now, under each one of those features there's a list of attributes as well. So there's a fairly well-defined GIS style data structure using XML for the transfer. It's an open source which allows any of the participating software platforms to share the data. So we'll get straight into the TBC side of this. So after you start a new project, if you don't have templates set up already, just use a metric 1. And using project settings, you can set your coordinate system. In this case, we'll just use the GDA 94, MGA 56, and OSGeodo 9, which is AHD, which stands for Australian Height Datum. Now, it's very important in ADAC to specify the feature definition file. This is central to the way that ADAC works in TBC. When using ADAC in TBC, if you're at the stage where you're still doing feature code processing, you can just leave these two checked. However, once you get to the point where you're starting to implement CAD edits in the software and you want to export XML and import XML for ADAC, just uncheck both of those so that it doesn't make any further changes on import export. So click OK to that one, and you can see that that has set up the layers. So to get some features so we can have a look at those, just navigate to this XML example. And we have a surface for this as well, so while we're there, we'll just put that in, but we'll turn it off, which we can do by unchecking this box. And we'll also just turn off the point IDs, so we can get a better look at the data. Now if we press F11, we'll be able to get the properties for this spatial object here, which is a line string, and has been defined as a non-pressure style pipe, and the layer sewerage. So these will all be the attributes with the attribute lists that come from the schema. So they're all available to be put in. Now the other thing is, on export, it will automatically pick up the invert level upstream and downstream from the object data here, as well as the link. And if you include the surface levels upstream and downstream, it'll also calculate the average depth. So the grade will also be automatically populated. So we'll have a look at that, and then we'll export round trip it so you can see what's going on. Some of the advantages that are available with TBC include the features spreadsheet, Now this shows the ADAC objects that we've got in there at the moment. For example, there's 24 circular sewer manholes, 28 non-pressure sewage pipes. So if we go through those, you can see that there's some that already have attributes against them. Now it looks like S14 is mentioned here twice, but that really should be S1A. So we'll just select those two. And just make a change there. Enter. And we'll just find out what this one out here is doing by itself. So we'll go back to the plan view. That's it there. And so it's just a little piece on the end. We won't worry about that for now. But normally you would update that with the attributes for the same line, if they were the same. So these ones down here are lines that haven't been identified yet. So you can see what's been selected is this one and these ones, but also this one down the end here. So if you hit Control Shift, you can deselect that. Now this line's going to be S2 and this line's going to be S1. So we'll deselect these. So now these ones can all be updated. We'll call it S2A. Just double check that you have nothing else selected. And this one can be S3A. This can also be used to create filters. So if you've got, say, water meter, and you want to find one in particular out of a list of thousands, you can create a custom filter that uses any of these conditions. It's a reasonably comprehensive set. In this case, we'll just go equals to. That allows us to isolate that one and select it. And you can see that it's point number 1082. So in the plan filter, we can zoom in anywhere. Go to point 0182, which is already selected. Center on that. And we can see it's that one there. So say if this was a whole suburb, it might be hard to find it, but that's an easier way. Now another thing we can go over is these stormwater lines. We'll just have a look at them in 3D. So go View, 3D. And if you use Alt, you can place a pivot point. Now there's meant to be a stormwater pit here between these two lines. In ADAC, the stormwater pit is a point. So we'll create a point. From the drop down list, we'll make it middle to point to point. And that'll put it on the right invert level between those two pipes. So that's the downstream invert level of that pipe and the upstream level of that pipe. So now if I select it, I can define it as a circular stormwater pit. Enter. And then fill out all of its associated business. There would also be one at the top of those pipes as well. So that's how you go through that if you didn't already have them there. Now as you can see, there's 3 road edges here, but depending on the jurisdiction they only really require 1. So that would be the invert there. And there's a few breaks in that, so I'll just join those together to give you an idea of how some of the edit tools work. So go join lines, join that one to that one, cross 3.731 meters, likewise here, and connect. Now I want that to be a closed figure, so in the properties I can just set the auto close to yes. And I can change it from a road edge to a pavement line, which then exposes all the associated attributes. Now when that gets exported, it'll be exported as a polygon. And if you make any mistakes or get anything backwards, you can just go back and change it very easily. And this one is the pavement, however I haven't joined it up yet, so I'll quickly do that. And auto close it. So now I'll take the auto close off that and just leave it on the pavement edge. And we change that to pavement line. So you can see it's pretty easy to edit things. So I'll just show you where everything lies in relation to the surface. So you can see that it's basically all under the surface. And I'll use the properties of the surface to change the visibility settings, because I don't want to see that wireframe and I want to have 60% transparency. So now you can see all the pipe works in 3D where it's meant to be. And that the road's sitting nicely on the surface. You can use that center line there. And what you do from there is select all of that. Under either the Home or Survey tabs, you can select the Export option. From Construction, there's the ADAC Exporter. You nominate where it's going. And this one we'll put back where we found it. Instead of example, we'll just put RTP, short for round trip, so that we can import it again and you can see the differences. Save that and export it. So we'll start a new project, and that shows that that's become a polygon on the import again. And it's retained all of the data that we put in there before. So it's fairly straightforward. ADAC's a smart format, given that it's got all the attributes associated with it. So one of the most strenuous parts of ADAC is just the data entry. You can notice that it's picked up the object data there. It does that for most things. So the last thing we need to go through is the ADAC settings. So that's the header information for the XML file. So if you type ADAC under the command pane, this comes up with ADAC props because it's a beta version, but the Trimble build has this as ADAC settings. And just click no, that gives you a little UI, which allows you to enter the header information for the project. And that'll tell you where the project is, the asset owner. For instance, Gold Coast City Council, as well as your surveyor information and engineer details. And we could have extracted the coordinate systems from the project settings, but just in case there's syntax difference between what the council's accepting or the utility's accepting and what TBC's writing, we'll just leave that so that it's user controlled. And also drawing extents can be just picked up from those two corners there. So once that's filled out and all the attributes are entered, you should have a valid ADAC XML file.